Okay, let us recap on what we did in polynomial last year. Okay, for the use of factor and remainder theorem. Okay, the first one on remainder theorem, when a polynomial function is divided by ax minus b, and we term this as the divisor, alright, we can make use of the remainder theorem, telling us that the remainder will actually be f of b over a. How to find this b over a is when you equate the divisor to be equal to 0 and find the corresponding value of x. So in this case, ax minus b is equal to 0, x will give us b over a. Similarly, alright, factor theorem actually tap on remainder theorem, except that factor theorem, the end result, or rather the remainder, will always be equal to 0. Okay, how to differentiate the use of remainder and factor theorem? Take note of the keyword. When you see the word divided, alright, this is only a divisor, you are expected to get remainder. Similarly, when you see the word factor or exactly divisible, you know that there will not be any remainder left. That is why the remainder in this case, with the use of the factor theorem, this is equal to 0. Okay, so this is a quick recap of what we did last year. Now we're going to take a look at this particular example. Okay, this particular polynomial, alright, this is a cubic polynomial, is exactly divisible. Because of the use of the word exactly divisible, Sharon, should we use remainder or factor theorem? Okay, factor theorem meaning all the remainder will be equal to 0. And this is divided by, or rather exactly divisible by this particular quadratic factor. Alright, so I'm going to write out the quadratic factor first. But now, a quadratic factor will not be useful. Alright, you will need a linear factor. So what do we need to do to this quadratic factor? Please make use of the F word, factorize. So I'll do a quick factorization over here. Alright, you notice there are two linear factors over here. Now, with the use of the factor theorem, because it's exactly divisible, so now, let Px be our polynomial function, or rather cubic equation. Now we are ready to apply. Because there are two unknowns here, obviously we need to apply factor theorem twice. Apply it for the first time. When x plus 2 is equal to 0, we substitute x is equal to negative 2 inside. So since this is factor theorem, there is no remainder, the remainder is equal to 0. Substitute inside here. Replace all your x by negative 2. So I'll do a quick one. Alright? This will be your first equation. Similarly, do likewise for the second one. When your factor is equal to x minus 1, meaning what value do we substitute inside?
A1,
1. Okay, you need to make x minus 1 equal to 0, so substitute 1 inside. Do we get any remainder? This is a factor. So factor theorem tells us the remainder will be equal to 0. So substitute inside. F1 is equal to 0. Replace all your x by 1. Okay, notice this is a pair of simultaneous equations. So just solve for A and B, you will be able to find the answer. I'm not going to solve the whole question for you. Okay, because Joel is laughing over there already. I shall stop the clip.